Hi everyone, let's see one of the question on synchronous counters. So they have given like define the circuit is self-starting or not. This is the first one, and second one is free running or not, and third one is if the present state is 001, what is the state after 4 clock cycles. So you have to solve these three questions. Okay, fine. So basically to solve this question you have to have know the meaning of self-starting, right? So self-starting means, if in counters, if I'm going to start at one state like something like 00, it can go with the next state, it can go with the another state, then it can go with another kind of a state, then it can go with another kind of a state, right? Yes. Or sometimes you may get a situation where you can get like this also. Sorry, it should be something 0 1 1 0 and something like this. Let us assume, right? This is one kind of a diagram, this is also another kind of a diagram, right? Now try to observe. Self-starting means wherever I am going to start, I can start it either 00, 01, 10 or 11. It has to compulsory enter into the loop, continuous loop. That is what we call it as self-starting. Means if I say technically, if a particular state is going to be started, if it is possible to enter counting loops, if it is possible to enter the counting loops irrespective of initial state, then I can call it as self-starting. Guys, can I say the first one is self-starting, this one is self-starting? Yes, definitely it is going to be self-starting. See, wherever I am going to start, definitely is going to enter into the infinite loop. But take out the second one, is it a kind of counting loop? No, it is going to have only one value, that is 0 only, right? So because of this point I can say that it is not self-start, right? For example, if I try to do one more thing, if I take 000, 001, 010, let me write some like I am writing something which might you understood. It will be something like it will be 1. So what might not start it? If I say, for example, 111, it has to be, right? Now can you tell, is it a self-started? Is self-starting? Yes, because for example if I start at 000, definitely is going to go for like this, and after some time definitely is going to be in loop. It is going to be in loop. So I can call this as self-starting, right? Yes. What about the meaning of free running? Free running means basically if the state diagram contains, if state diagram contains all possible states are there, right? If state diagram have all possible states, if all of those going to participate in the counting loop, I can call it as free running. Now can you tell, is the first one is it free running? Yes, it is going to be free running. Why? Because whatever the states are there, all the states are going to be entered into the loop. What about the second one? Second one is not free running. What about the third one? Third one is also not free running. Why it is not free running? Because only few states are going to participate in the loop. That's why I can say that it is not free running. Okay, fine. So guys, can I say that with this thing, can I say that every free running is a kind of self-start? Yes, right? So if I say every free running, if I say that it is free running, definitely it is self start, it is self starting, but vice versa is not possible, guys. See, the example is this one itself, right? If I say it is self starting, it is not going to be a free running, so this is important. Okay, fine. So now the question is, once you know the meaning of it, you have to have state diagram. You have to get the state diagram, right? How can you get the state diagram for this kind of circuit? You can able to draw the excitation table, right? So if you are going to draw the excitation table, if I say Q2, Q1 and Q0, Q2, Q1 and Q0, how it is behaving you have to identify, right? So the next states are Q2n, Q1n, Q0n. So 000, 001, 010, 011, 100, 101, 110, 111. So try to observe here. Here basically you can able to solve it easily. See, think about this diagram. If I am going to be having the present state like this, these are the next states, right? So how can we get the next state value? Q0 is getting because of D0, Q1 is getting because of D1, Q2 is getting because of D2, right? So if you are able to clearly write, Q2 next state is going to be the value of D2, right? But D2 value is going to be the value of Q1, D2 value is going to be the value of D1, Q1, right? So Q2n I can directly write as Q1, Q2n I can write as Q1, right? So I can simply write 00. So all those things I am going to write directly. 00, 11, 00, 11. What about the Q1n? Q1 is going to be D1, which is going to be a Q0. So Q1n is going to be Q0, right? So 01, 01, 01 and 01. What about Q0n? Q0n is going to be D0. But what about the D0? D0 is XOR operation of Q1 and Q2. XOR operation of Q1 and Q2, right? So XOR operation of Q1 and Q2, which means that, so when both are same, your result is going to be 0. When both are different, your result is going to be 1, right? So Q1 and Q2 same, so it is 0, it is 0, it is going to be 1, 1, it is 1, 1, it is going to be 0, 0. That's it, right? Now once we drawn this particular table, can you able to go with the state diagram? Yes, right? So if I am going to present at 0, 0, if I am going to present at 0, 0, what might be the next state? Next state is going to be 0, 0, 0 only, right? Next state is going to be 0, 0 only. If I am going to present at 0, 0, 1, 0, 0, 1, next state will be 0, 1, 0. If I am going to present at the 0, 1, 0, next state will be 1, 0, 1. If I am going to present at 1, 0, 1, 1, 0, 1, next state will be 0, 1, 1. Okay. If I am going to present at 0, 1, 1, next state will be 1, 1, 1. It will be 1, 1. If I am going to present at the 1, 1, 1, next state will be 1, 1, 0. Next state will be 1, 1, 0. Let me try to extend. If I am going to print at 1, 1, next state will be 1, 1, 0. If 1, 1, 0 is there, next state will be 1, 1, 0. Next state will be 1, 0. If it is 1, 0, next state will be 0, 0, 1. So next state will be 0, 0, 1. Right? So I think all are covered, right? So total 1, 3, 6, 7, 8. So total 8 states are covered, right? Yes. So this is the corresponding state diagram for the given circuit diagram. Now with this you can able to solve all the questions. Is it a self-starting or not? Answer is, for option for question A, the answer is it is not self-starting. why it is not self-starting? Because if I am going to start at one point of time, it has to be continuously enter into the loop. But if you are going to clearly observe, if I start at this point of time, it is not going to enter into the loop. It's going to be only counting only 0. That's the reason. If at least one thing is failed, so I can say that it is going to be not self-starting. What about, is it free running? Just check about it. If it wants to say free running, it has to have a loop, and that loop contains all states. So it is not going to be a free running also. Not going to be free running. Yes. What about the question C? If the present state is 001, present state is 001, what is the state after 4 clock cycles? Right? So this is first clock cycle, second, third, and fourth. So after 4 clock cycles, your result will be 111. See, simple. It's as much as simple. If I am going to present at this point of time, this is first clock cycle, second clock cycle, third clock cycle, fourth clock cycle. Meaning that once I apply first clock for the 001, I will get 010. Next time I apply clock, I will get 101. Next time I apply clock, 011. If I apply next clock, that will be 111. So that is the reason. Right? So if you want, so what will be the state? So if they ask specifically, what will be the state after 10 clock cycles? 10 clock cycles, if I am going to present at 001. So what you can do, if you are present at let me take the blue. If I am present at the 001, after 10 clock cycles, what will be 1? So up to here it is 4, 5, 6, 7, 8, 9, 10. Then it will be the answer as 011. Right? But the way you are going to count, is it going to be correct one? For example, if they are asking for after 117 clock cycles, after 117 clock cycles, then how can we do this? Right? So it is simply a kind of multiples of 7, right? The loop is going to be repeated for multiple of 7, right? So simply divide 117 with the 7, right? Meaning that you have to write in terms of modulus 7. Modulus 7. You are going to get, I think, 7 1s are 7. 7. You will get again 4, right? 7 6 are 42. 42, right? So the remainder is you are going to get as 5, guys. So the remainder will be 5, meaning that 117 clock cycles is equivalent to 5 clock cycles, equal to 5 clock, right? So after 5 clock cycles, what will be the answer? So it will be, the answer is 110. So 110 after 117 clock cycles. So like this, your gate questions may come on. I hope you understood clearly. Thank you.